A lot of you could probably do this one in your head. Hopefully it's kind of trivial. Um, if it's not, just keep chugging away at it and hopefully you'll get there that you can see this one. I'm going to do it in a little bit of a longer way to show you a little bit of notation that may or may not help later on. So if you've got the answer, go for it, but either way, watch this little video clip so you can see the notation. Reading through the question, it says that the toy plane is flying 5 meters per second north relative to the air. That's the velocity, so V for velocity with the little vector hat. I usually put a little arrow on it when I draw it. That's V for velocity. That's the velocity of the plane, P for plane, relative to the air, so A for air. And that was 5 meters per second in the north direction. Vector notation, we usually put the direction in square brackets after the number in the unit, so that there is velocity of the plane relative to the air is 5 meters per second. If we keep reading the question, we get to this. The air is moving at 2.5 meters per second north relative to the ground. That's another velocity, so V with a vector hat. That's the velocity of the air relative to the ground. So I put an A up front for air and a G back here for ground. And that was equal to 2.5. The units are meters per second, and that's also pointing north. The question wants to know, the last little piece is, the resulting velocity of the toy plane relative to the ground. So to finish this off, I'll switch colors one more time. The question's asking for the velocity of the plane with respect to the ground. If this subscript notation, if it starts to make sense, where it gets helpful is, I want to know the velocity of the plane relative to the ground. To get that, I'm going to take the velocity of the plane relative to the air and add the velocity of the air relative to the ground. So it's almost like that inside A cancels with that inside A. To get all the way from plane to ground, we take plane to air and add air to ground. Now to practice our arrow drawing, this one we could do in our head. It's literally just 5 plus 2.5. But to practice our arrow drawing, draw the first vector. That's the 5 pointed in a northern direction. Oops, pretend that's a straight line. So that's a length of 5 meters per second. Where that ends, we're going to add the next one, 2.5. The answer is a line that connects the very, very start to the very, very end. I'm going to drop aside a bit so I can see it better. So just kind of, again, just literally adding them up. The answer to this one is 7.5 meters per second, and it happens to be pointing north. Hopefully the notation doesn't bother you too much, but that's the notation we'll use with relative motion when we have to write it out. If you can just draw the lines, draw the arrows without the notation, that's okay too. But later on I'll use it a little bit more often.